The average man in his lifetime will eat 50 metric tons worth of food. That's the equivalent of 140 cows, 10,000 salmon, or 300,000 potatoes. It's a hell of a lot of food to put through a digestive system. This week, Aoibhinn takes a voyage deep into inner space. Kathriona puts herself and her guts under pressure.
Why can't I do this?
And I'll be finding out how the way you were born can influence the bacteria in your gut. Irish eating habits have changed a lot over the years, and we're now eating a more diverse diet than ever. Excuse me, guys, can I borrow for 2 seconds? Have either of you eaten anything unusual?
Crocodile steak.
Tongue of horse tongue.
Horse tongue?
Yeah.
Probably snails or something on holidays.
Snails.
A snail.
Rooster feet.
Liver's just so disgusting to me.
And when I was in France, actually, they eat this thing. It's like raw meat and raw eggs, like mashed up. That wasn't nice.
If I were to put snails on your plate or tongue...
No way. No way.
But just how does our body process this food? And how much do we actually know about our gut?
Food is essential for our bodies to function. But while we've all heard about the importance of having a balanced diet and eating healthily, not many of us know what actually happens to this food when it's inside our bodies.
André Broadkorb is a Teagasc research scientist with a particular interest in how food is digested in the stomach. He's actually gone so far as to volunteer to swallow a tiny pill camera so he can track the movement of a specific protein as it moves through his digestive system.
There's actually surprisingly little knowledge on how food is broken down within the gastrointestinal tract. So what I'm interested in is how proteins behave during that process.
So we're going to just ask you to swallow the tablet. This capsule is going to take 3 pictures every second of your gut, and we're going to let it run for 8 hours. So by that time we will have seen all your stomach, all your small bowel and some of your colon. Do you want to pull it out there for me? Very good.
Why is it flashing?
Well, it's flashing because inside our guts it's dark, and one of the main purposes of this tablet is so we can see the mucosa inside. So it needs to light the way so we can see the lining of your gut. We're good to go. Now it's specially coated to go down nice and easily. So down the hatch. Well done.
It's a few weeks later and I'm paying a visit to André's office in Teagasc Moor Park to find out what the camera recorded when it went through his gut.
So André, this is the footage of you swallowing a camera.
Yeah, what you see here is the pyloric valve. There we go. You look into my pyloric valve. And that's basically massaging food. If you have a steak in here, that's what it does. It massages the food until it is small enough to be further digested. And what this is the alpha-lactalbumin, the protein, the whey protein, just arriving in the stomach and coagulates, basically sticks together.
So what we're looking at, are we looking at things coming from the esophagus there?
Yeah.
There's a reason why I did physics. I'm quite squeamish and I don't like looking at this, but it's quite unusual to have footage like this to see inside someone's digestive system.
It is very unusual. It is used as a diagnostic tool by gastroenterologists, but it's the first time that has been used for food, for scientific study. If we understand how digestion works, we can design or create better or new foods that are suitable for individual needs. Let's say a triathlete or a marathon runner or elderly person has different nutritional needs than somebody that wants to lose weight.
One of the things we do know, however, is that food is broken down in the stomach with the help of various acids and enzymes. This has the added benefit of killing bacteria that might make us ill. But what about the good bacteria?
They're killed, simple as that. But depending on the matrix, depending on the surrounding of the bacteria, they might survive. So they survive pretty good in a matrix such as yogurt and dairy proteins because they buffer the pH.
So by matrix, you mean in this sense the other foods that we're ingesting at the same time?
Exactly. What we try to do is that the consumer doesn't need to think about that. So that's really our aim, that we have some kind of food or functional food that can be consumed, and the probiotic bacteria that actually survive the stomach. So that's one of our aims, and we had one particular project, and one of the solutions is encapsulation.
Encapsulation is a process where active sensitive food ingredients like probiotic bacteria are coated with a protective shield so they're not damaged or destroyed by either the production or the digestion process. Instead, they can deliver their health benefits to the right part of the body at the right time without being damaged in the gut.
We've all seen the ads for probiotics that promise to make our guts healthier, but helping these probiotics make their way through our digestive system is where encapsulation technology really comes into its own.
Sinead Blyle founded her company Anna Biotechnologies after completing her PhD at Teagasc Moore Park. She aims to meet the needs of the food industry who want to create functional foods that provide health benefits to the body.
What we are doing is actually making food-grade capsules, but micron-sized, like a mini Smartie. So if you think of a Smartie, but so small that you need a microscope to see it, and we're making coatings, maybe only one coating or 3 or 4 coatings around this material, so that the capsules can protect probiotics, and that can go into a beverage, a muesli bar, a powdered product. So what encapsulation does is it ensures that whole population, that whole massive family of probiotics is delivered and is happily sitting in the gut after you've eaten your yogurt or your muesli bar, whatever it may be.
So you're making sure that it's getting opened at the right time, at the right address, not beforehand and not afterwards.
Exactly.
So where does Sinead see encapsulation technology going in the future?
There's a big trend in functional foods moving towards vegetarian-friendly ingredients, more vegetable proteins. Milk is still very sexy and very popular, and we can maintain that market, but it's also important to try and find new innovative ingredients like extracts from citrus fruit that can still be used in encapsulation. But it's also important balancing, can those ingredients function in encapsulation, and are they allowed in the regulations for food? So it's a matter of fixing the ingredient and fitting it to the correct market, whether it be sport, infant formula, or general dietary supplements for human health.
Do you go for, like, you know, these probiotic drinks? Do you ever think about the bacteria in your gut or anything?
I have thought about bacteria in my gut, but I have never had a probiotic drink.
I was having some problems digestively, and I think they were fantastic.
No, not at all. Just eat food.
Like drinks, right? Yeah, I think so. Probably. I don't know. I've drank a lot of stuff. So.
Well, some of us seem happy with the idea of taking food supplements to improve our health, but could there be a link between good gut health and the brain? Kathriona is on her way to UCC to find out.
We've all heard the expressions gut feeling, gut wrenching, or trust your gut. But what if the secret to our happiness is dependent on the bacteria in our gut? Now, I've had my gut bacteria tested in the past, and they're pretty happy by all accounts. But what if I were to stress them out a little? Why would you want to do that, I hear you ask? Well, scientists have identified a link between the happiness of the trillions of bacteria living in our gut and the brain. If one is put under stress, then the other can start to feel the pressure as well. At the APC Microbiome Institute in Cork, Professor John Cryan is investigating how our gut microbiota influence our brain.
I think what we're beginning to really appreciate is that to have a normal brain health, we need to have a good digestive health. So it's kind of like, you know, TV shows like Downton Abbey or Upstairs, Downstairs, where you have these two populations that live in the same house, oblivious to each other. And it's only when things start to go wrong downstairs that all the drama occurs upstairs.
The bacteria in our gut weigh around 2 kilos, and there's a growing appreciation they play a critical role in all aspects of our health.
These bacteria are like little factories for many types of neurotransmitters and neuroactive agents. And these bioactives can then influence the gut physiology, but also influence the signaling from the gut to the brain.
One way the brain and the microbiome communicate is through the vagus nerve, a long, wandering nerve that carries information in both directions.
Studies from our lab here have shown that this vagus nerve is critical for sending signals from certain bacteria all the way to the brain to influence how we deal with stress and how we behave.
John and his team of researchers use a range of different experiments to see what happens when healthy volunteers are put under stress and if this impacts on their gut microbiota. I've asked if I can try out some of their tests, even though it means doing something I hate, mental arithmetic.
We would like you to start at 2023 and subtract in 17 number steps. If you miscalculate, you will be told so, and you will have to begin again at 2023. Please begin.
So 2023 minus 17 is 2006. 2006 minus 17, 7 from 6. 1,899.
Error. 2023.
2006, 1,972, 1,965.
Error. 2023.
Oh, why can't I do this? 1,912.
Error.
Aoibhinn should have done this gig. 1,972, 2006.
Error, error, error.
I'm not sure my gut bacteria will ever recover from all those sums. But on a more serious note, the tests carried out here in UCC are helping researchers develop ways to enhance the bacteria in the gut so they can have a greater positive impact on the brain. So could a simple pill like this help us harness the power of our gut microbiota to improve our mental health? I'm meeting psychiatrist Ted Dinan, who's interested in the development of psychobiotics. These are the next generation of bacteria that, when eaten, could work on the brain and the gut to improve mood and emotions.
I don't envisage a scenario where one would be using psychobiotics, let's say, to treat very severe forms of depression. But I do believe that milder forms of depression and mild forms of anxiety will be treatable with psychobiotics. I'd be very surprised if we don't have psychobiotics for treating depression and anxiety on the market within 3 or 4 years.
And it would be kind of a benign treatment. It's not going to do much harm.
Absolutely, very benign. I mean, certainly all of the probiotics that we've worked with here that we've put into humans have been free of any side effects.
John and Ted's research has received acclaim worldwide, but there's still a lot to be done as they work through the vast numbers of bacteria in our gut to find out which ones have a potential psychobiotic effect.
Only a tiny percentage of them, maybe as small as 1% or less, actually have psychobiotic potential. So the real challenge is to detect the ones that have and to dismiss the ones that really are useless.
We know having more diverse bacteria in our gut can improve our physical and mental health, but the next phase of treatments might seem a little gross at first.
Fecal microbiota transplantation, which is exactly what it says on the tin.
It's taking someone else's poo.
Absolutely.
Yes, folks, he's talking about transplanting poo from one person to another. In fact, fecal transplants are already underway in humans by transplanting material directly from one gut to the other. But soon there could be a poo pill. Any takers?
There's some intriguing work coming from animal studies where they've looked at 2 different strains of animal that have different anxiety levels, one high, one low, and they did a transplant. And they were able to show that you could turn a normal mouse into a highly anxious mouse and vice versa. So if this could be translated into the human situation, you better be very careful about who you get your donation from for such transplantation.
Yeah, you want to know their psychological profile.
Absolutely.
Coming up after the break, we look at the gut-spilling antics of the sea cucumber. And Jonathan meets the scientist mapping the future of baby food.
We all know that good gut health is crucial in defense against disease. But for the sea cucumber, defense really takes guts. This is a small, slow-moving, brainless animal, surely ripe for the taking by any predator. But even though it doesn't have a brain, it is one of the strangest but cleverest forms of defense. When attacked, the sea cucumber self-eviscerates. It literally spills its guts in a last gasp fight for survival. But how? The sea cucumber has a special type of tissue called catch connective tissue, with the unique ability to harden or soften in a matter of seconds. This allows the sea cucumber to control the strength of its internal tissues at a whim. When attacked, the tendons and ligaments that support internal organs rapidly soften. A small rupture forms, its internal muscles contract, and its insides are shot outwards. Often these entrails are coated with toxins for added protection. But surely, this act must spell the end for the sea cucumber. It is, after all, self-mutilation. But not so. Some of its cells revert back to stem cells, which then regrow into organs, allowing the sea cucumber to regenerate from the inside out and bring a whole new meaning to good gut health. See you next time.
The food that we eat every day has a huge effect on the bacteria that live in our gut. And this in turn has a huge effect on how we feel, both mentally and physically. And this is even more true for those who are just starting out in life.
The first 2 years of life are a very critical period for interventions to promote the best outcome in terms of development later in life. It's also during that period that the microbiota is established, and it's in a state of flux over the first couple of years of life until it settles down beyond 2 years of age.
In order to learn more about the types of bacteria that live and grow in a baby's gut, Catherine and her team at Teagasc Moor Park have been following the development of 150 babies since they were born as part of a project called InfantMet.
We established the InfantMet programme a few years ago, where we recognised the importance of early gut microbiota in health and wanted to establish the baseline microbiota associated with breastfeeding, which is the gold standard infant nutritional regime.
Breast milk is an extremely complex substance, so is it possible to recreate it or synthesize it in a lab?
Well, indeed, you're right. Breast milk is extremely complex, and in particular, it has a large array of complex polysaccharides that actually aren't digestible by the infant gut, but are digestible by the microbes.
So you're saying that in breast milk, there's not just food for the baby, but also for the bacteria as well?
Absolutely, yes. And because the baby cannot digest these complex polysaccharides, but the microbes have the enzymatic machinery to do so.
The way babies are born can affect the growth of their microbiota. So researchers were keen to find babies that were delivered naturally, by cesarean section, and prematurely. And where better to find them than at Cork University Maternity Hospital, where babies come in all shapes and sizes.
InfantMet is important for us in the unit by just collecting stool samples, measuring the babies, doing neurodevelopmental checks on them at 2 years. They're providing us a lot of information. Irish mothers are providing us a lot of information. And we have found that the Irish families are very, very altruistic and will participate in these studies.
One of the many children who took part in InfantMet is Aoibhinn Lynch from County Cork.
And I had a cesarean section to bring Aoibhinn into the world because he was very comfortable. He was born at 42 weeks and it was time to let go. I was really happy to meet him. Caroline asked if we would like to contribute to the study. We had a schedule, so when Aoibhinn was 2 weeks and 4 weeks and 6 weeks, we took samples from Aoibhinn. So the samples consisted of Aoibhinn's poos. So, you know, we didn't need them, so we may as well donate them on to a much better cause. It's actually really nice to see that contributing to a research project was actually part of our lives, you know, and it's nice to see that research can be integrated into very, very normal activities. And it was absolutely no trouble and it was a pleasure to be involved.
Ciara Murphy and Claire Watkins have been analysing the samples provided by Aoibhinn and the other babies in InfantMet.
What we do is we extract the bacterial DNA and then we use DNA sequencing to identify what bacteria are living in the sample.
Why is it useful for us to know about the types of bacteria that are in the guts of babies anyway? What can we do with that?
It's been shown that infants born by C-section and preterm infants, that they tend to have higher rates of things like asthma, allergic diseases, and they're more likely to become obese later on in life. So our theory is that these differences in the microbiota composition could be linked to these health effects that we're seeing in these infants as they're older. So we're hoping that the information that we've learned here in InfantMet, the differences in their microbiota composition, that we can use this in the future possibly to develop probiotics that we can give these infants who were born by C-section, who are preterm, and try to repopulate their microbiota into a manner that's more similar to a full-term naturally delivered infant.
The samples provided by babies like Aoibhinn are helping to build a picture of what's been happening in their guts since the time they were born.
We take our fecal samples into a pathogen lab where we isolate them for specific types of bacteria, and we have to recreate an environment very similar to the gut. So we might take 3 or 4 days for them to grow on a plate until you can see them, and then we can pick them and grow them up and stock them. So we keep them in a freezer indefinitely at -80 degrees, and then we can grow them up again then to test them and look for different things like if they can survive acid or bile and different things that they would have gone through in the gut. This is a plate of lactobacilli, which we've grown up from one of the fecal samples, and I'm testing it for different probiotic traits just to see if it can survive the gut and if it can produce anything that would be beneficial for the infants later on.
And this is a type of bacteria that we see in the feces of very healthy infants.
Exactly, yeah.
What are you hoping to learn from this bacteria, Claire?
Well, what we're looking for is really the best kind of probiotic trait. So the better that they can survive this acid or bile, then if we ever try to feed it to an infant again, then it should be able to survive the gastric transit.
Studying the bacteria that thrive in a healthy baby can help scientists learn more about infant health in general. But of course, the potential for this research is huge.
We know that reduced diversity in the microbiota is associated with incidence of allergy and other lifestyle diseases later in life. So fundamental research to understand what bacteria and what microbes, what are the causative factors of such later lifestyle disorders is vitally important for the future health of the population.
Anything that helps us understand how babies grow and develop is hugely beneficial. But it doesn't stop there. Ireland produces around 15% of the world's infant formula milk, and so the findings from InfantMet could help companies develop new types of food for babies all around the world.